What is so neat about a pineapple? Could it be that it's just another fruit you can buy at the grocery store? Besides, sometimes it can be too bitter to eat immediately. Hey, it can also take a long time to mature in size and turn into something desirable. At first glance, it may seem that there isn't really anything considerable to say about a pineapple. Last time it was up for nomination, 1,000 more votes went to oranges and apples. Even watermelon surprised the critics. Sometimes fruits like a pineapple can really be overlooked and be considered not much of special. Today, I would like to talk to you not really how tasty a pineapple can be or how difficult it can be to cut it up into sizable pieces at the very first try. Instead, I want to focus on something special that is on the side of the pineapple. This means that the pineapple really is special and there's something neat about it. So what am I talking about? Well, this sequence has been known for hundreds of years, known as the Fibonacci sequence. Today, in this short presentation, I would like to share with you how the Fibonacci sequence demonstrates order in series of numbers, efficiency in nature, and beauty in relations to the golden ratio. So order in the series of numbers. In order to have this work, I'd first like to explain what is the Fibonacci sequence. If you were to research the Fibonacci sequence, the very first thing you'd likely to find is 0, 1, 2, 3, 5, 8, 13, 21, 34, and so on. So these numbers follow a pattern. This means that there is logic behind this. If you apply this rule, you can use it on larger numbers, such as 144 and so on. So let's pick a number to begin, such as 5. That's an easy number. How do you get 5? Well, we said it was 0, 1, 2, 1, 1, 3, 5. This means that 2 plus 3 will give you 5. Do you see the pattern? 2 plus 3 gave you 5. So if you add 5 plus the previous number, which was 3, you get 8. And how did you get the next Fibonacci number? Simple. Add 5 plus 8, 13, and so on. So you see that there is order in the Fibonacci sequence, but there is also efficiency in nature. And this is what I want to talk to you about next. What are some popular examples of efficiency in nature? Well, you have the nautilus, you have pineapples, you have pine cones, flowers, and even us humans have the Fibonacci sequence within us. Let's take a popular example like the sunflower, and looking at it more specifically, as the Museum of Mathematics explains in their article, Mathematics Fibonacci Numbers of Sunflowers, Fibonacci comes into play in the scene because the numbers follow Fibonacci numbers, 21, 34, and 55. So if you were to take a sunflower, look at the center, you would notice that it has seeds, as many of us know, but these seeds don't just grow there, they grow in a spiral. And these spirals grow clockwise at a very specific angle, 137.5. And they follow the Fibonacci numbers, 21, 34, and 55, allowing for efficiency and compactness within it. But let's talk about another example that I mentioned, the pineapple. This has the Fibonacci sequence within it. If you look at it, these seedlets, 13 will go in this direction, 8 going down, and 5 in the other. This is true of most pineapples as long as they're close to perfection. But this shows that in nature there really is the Fibonacci sequence allowing for efficiency. Now, after looking at the sequence's efficiency in nature, we will be looking at its relations to the golden ratio and beauty. What is the golden ratio? Well, as Mr. Alford explains in his book, Glorious Golden Ratio, it's the division of a given line segment into a unique ratio that gives an aesthetic, pleasing proportion. And guess what? The Fibonacci sequence is found here. So take one of the numbers such as 55 and divide it by the previous Fibonacci number, 34. You get 1.618, which is known as phi, the Greek symbol for this golden ratio. 1.618. And interesting, it's very pleasing to the human eye, which as a consequence means that throughout history, many works of arts have been known to have this within it, such as the Mona Lisa, King David, which is a statue, and even the Apple logo has the golden ratio. And one very interesting one is the Vitruvian Man, work of Luca Pacioli, who used the golden ratio to relate the height to the navel to the total height of this drawing. In the book Mathematics and Illustrated History of Numbers, Mr. Jackson explains how this illustration is very symmetrical and uses the golden ratio. In conclusion, I hope to have informed all of you about the Fibonacci sequence and its influence in many aspects of math, art, nature, and much more. It has been fascinating to recognize the order, efficiency, and beauty in the sequence. The golden ratio is related to the Fibonacci sequence, and both things really bring beauty to many parts of our lives. I hope to have sparked some interest in you about this topic. And will you continue to see pineapples and sunflowers with the same eyes?